Hello YouTube, welcome to the channel. So today I'm going to be discussing the chain rule for taking derivative of composite function in calculus. So the chain rule is utilized when a function is contained within a function. For example, if you have the function sine of x, which can be changed to the function sine of cosine of x. This would be an example of a composite function because you have a function contained within a function. And for these types of function, to take the derivative, we must implement the chain rule. So I assume that you guys are already familiar with the derivative of certain functions of x. For example, the derivative of sine of x is cosine of x, right? Now the question is, what is the derivative of sine of cosine of x? Well, if you look at that, that might be confusing, right? Because you have two functions here, one function contained within another. So how do we go about taking a derivative? Well, we implement the chain rule. And the chain rule goes as follows, right? So if you look here, these two functions, the sine of x and sine of cosine of x, look very similar to each other. The only difference is that the argument in this function is x. It's the sine of x. However, in this function, the argument is cosine of x. It's the sine of cosine of x. Well, here's what I'm going to do. I'm just going to treat this function like I did the above function. So I'm just going to treat cosine of x like it's just x. And I know that the derivative of sine is cosine. So I'm going to just do what I would do if it was just x. So just put down cosine. And then rewrite the argument cosine of x. However, this function is not x. This function is cosine of x. So I can't just write cosine of x because this function is not just x, it's cosine of x. So what we must do is we must multiply by the derivative of this function here. And what's the derivative of cosine of x? It's minus sine of x. And that completes our derivative for this function. Okay, so let's try another function. Let's take the derivative of e to the x squared plus cosine x. What does that equal? Well, this function looks a lot like e to the x, and we know that the derivative of e to the x is e to the x. However, this function is more difficult, right? Because the argument is not x, it's not just x. The argument, it's e to the x squared plus cosine x, which is not just x. However, this looks like e to the x. So I'm just going to treat this thing here like it's just x. And so what would be the derivative if it was just x? Well, the derivative of e to the x is e to the x. So I'm just going to rewrite e to this argument x squared plus cosine x. However, remember this thing is not x. It's x squared plus cosine x. So what I must do is I must multiply by the derivative of this thing here, which is x squared plus cosine x. So what's the derivative of that? Well, the derivative of x squared is 2x, and the derivative of cosine x is minus sine x. So minus cosine x. And that will be the derivative of this function. Okay. Alright, so I hope that clarified things for you guys. Gives you a more intuitive way of knowing how to apply the chain rule to find the derivative of composite functions. Thank you guys for watching. Bye bye.